Hello and welcome to another past paper session. Today, what I'm solving is a set of questions from the S1 past papers that I think are difficult. Okay, they are from various different papers, so I can't tell you which paper to open up. But you can find the question on the screen. This is from March 22. Paper is 5.2, and this is question number 2. It says in a certain country, the probability of more than 10 centimeters of rain on any particular day is 0.18 independently of the weather on any other day. Find the probabilities in a randomly chosen 7-day period. More than two, more than two have, uh, okay, so more than 2 days have more than 10 centimeters of rain. Okay, so I want to find the probability of x greater than 2. That means I want to find the probability of 3, 4, 5, 6 and 7. Instead, what I can do is I can do 1 minus probability of 0, 1 and 2. Okay, so what I have here is then a binomial situation. So I would want to know what my small p is, what my success is. So if my success is getting 10 centimeters of rain, which is 0.18. So I'm going to write my expression 1 minus 7c0 0.82 power 7 minus 0, 0.18 power 0, 7c1, 0.82 power 7 minus 1, 0.18 power 1, 7c2, 0.82 power 7 minus 2, 0.18 power 2. Okay, putting this on my calculator and getting you some answers. 7, I don't know, let's see, D2 to 7.18. So I'm getting 1 minus 0.8846. That gives me 0.1154. Okay, rounded off to three significant figures is 0.115. Okay, let me just open up the marking schemes in front of me so that I know what is happening. Um, June 22. Okay, then it says for three randomly chosen 7-day periods. Now remember that I'm not talking about days of a week now. I'm talking about three periods. So n is equals to 3. That's what I'm talking about. Okay, that is something that you have to notice first. Okay, then it says find the probability that exactly two of these periods. So I want to find the exactly of two periods have at least one day with more than 10 centimeters of rain. Okay, so each period now has to be successful. Now my success is at least one day with 10 cm of rain. Now remember that this is one binomial feeding into another binomial. So what you need to do first is you need to say that I will calculate this too later on. But right now what I want to talk about is one period. One period is 7 days. Okay, what do I want? My probability of success is that days is greater than or equals to 1. Okay, how do I get days greater than or equals to 1? I subtract probability of days equals to 0. So 7c is 0, 0.82 power 7 minus 0 and 0.81. Okay, so this is the first binomial, the success from one period feeding into another period. So I'm getting 7507. So how do I find the probability of 2 now? I know that I have a total of 3 periods, so 3c2 point, that's the final answer, I think. 0.2493 power 3 minus 1, 0.75075. 139969. Okay, 0.140. Okay, I'll have to check what I did wrong here. I think I rushed through the calculations. Oh, this is 2. I messed up the numbers. 0.421. Okay, so that's the first set of difficult questions. Let's go on to the next one that I have here for you. This is question number 6 from the same paper. Okay, it says a factory produces um, chocolates and flavors lemon, orange, and strawberry in the ratio 3:5:7. Nelson just checks the chocolates on the production line by choosing the chocolates randomly one at a time. Find the probability that the first chocolate with lemon flavor that Nell chooses is the seventh. Okay, so when I talk about the first, I am talking about a geometric situation. Okay, so I want the probability of x equals to 7, and I'm going to say that how do I find out q power r minus 1, p power 1. What is a p? Nell chooses the first chocolate with lemon flavor. So what is the success? Lemon flavor. Lemon flavor is 3 out of 15. That's 1 out of 5. Okay, so that's 4 out of 5 power 6 into 1 over 5. I hope that's the correct answer. Okay, yeah, that gives me 4096 over 78125. If you want to round off to three significant figures, it's 0524. Okay, question part B says find the probability that the first chocolate with lemon flavor that Nell chooses is after she has checked at least 6 chocolates. So I want probability of x greater than 6. Okay, I want to check that I'm successful on the seventh. So probability of x greater than 6, that means I'm either successful on the 7th attempt or 8th attempt and so on, because after she has checked at least 6 chocolates. Or I can also say that it's greater than or equals to 7 if I want to say. So I am successful on the 7th attempt and so on. So this is just q power r then, and 4 over 5 power 6. Okay, 4 over 5 power 6 gives me 0.262. Okay. Okay, so this question says surprise boxes of chocolates each contain 15 chocolates, 3 are lemon, 5 are orange, and 7 are strawberry. Petra has a box of surprise chocolates. She chooses 3 chocolates at random from the box. Okay, now remember that the previous question was an unlimited amount of chocolates. So I was doing a geometric progression where my success was the same. In this case, I just have 15 chocolates, which means that the probability of my next chocolate will change. Okay, so I want that 3 chocolates has none of the 3 chocolates has orange flavors. So I want orange not, orange not, and orange not. How many are orange not? 3 and 7, 10 are orange not. So 10 out of 15, then 9 out of 14, and then 8 out of 13. Let's see if we get the correct answer. I could do 3 factorial, but I'll have to divide by 3 factorial again. 24 over 91. Okay. Let's just find the probability that each of Petra's 3 chocolates has a different flavor. So I could get lemon, orange, and strawberry. Lemon, probability of lemon, orange, and strawberry, but I could get them in any order. So I'm going to say that 3 over 15, 5 over 14, and then 7 over 13 into 3 factorial. Why? Because they could come up in any order then. Okay, so 3 into 5 into 7 into divide by 15 into 14 into 13. 3 over 13. Okay. Find the probability that at least two of Petra's three chocolates has strawberry flavor given that none of them has an orange flavor. So at least two strawberry. Okay, this question could have been done with the tree diagram as well. Given none has orange. None has orange. So what I can say now is that the denominator will be none has orange. Okay, and the numerator will be at least two strawberries. So I will have strawberry, strawberry, and orange. Uh, and okay, strawberry, strawberry, and lemon plus strawberry, strawberry, and strawberry. Okay, at least two strawberry, and none of them have to be orange, which means that the numerator should have both conditions. Okay, it cannot just have one condition, it needs to have both conditions. So none has orange is already there. What was my answer to the previous part? It was 24 over 91. So I'm going to place that in the denominator, and now I'm going to find strawberry, strawberry, and orange. How many have um, this is LOS, not LOR. 7 are strawberry. So 7 are strawberry, 6 are strawberry, and then 3 are lemon. Into 3 factorial divided by 2 factorial plus 7 over 15, 6 over 14, and 5 over 13. Let's see if we get our correct answer. You can drop your questions in the comments if you have any. 3 over 130. 1 over 13, and then 24 over 91. Okay, so that's giving me 91 over 240. I don't know if that is the right answer. I will have to check. Uh, 3 over 13 was the previous one. Let me check if I've made some calculations mistakes. 7 into 6 into 3. I think I made some calculation mistake somewhere, so I would want to check that. Typing all of this stuff on a calculator. The working seems correct. I think I missed the 2 factorial in the denominator. That's what I've done. Yep, it's 9 over 65 plus 1 over 13 divided by 24 over 91. Yep, that's what I missed. That's what I thought I had not typed into my calculator. So just be careful what you're typing on your calculator. You could lose out on 1 mark if you don't get the answer correct. The rest of it is fine. Okay, moving on. Let's see what other tough question I have. The next tough question that I have for you is from June 2251. Janice plays a computer game. She has to complete level 1 and level 2 to finish the game. She's allowed at most 2 attempts at any level. For level 1, the probability that Janice completes it at the first attempt is 0.6. If she fails at her first attempt, the probability that she completes it at the second attempt is zero point 0.3. If Janice completes level 1, she immediately moves on to level 2. For level 2, the probability that Janice completes it on the first attempt is this. If she fails, the probability that she completes it on the second attempt is zero point 0.2. It's a long game. When you have a game, it's best to draw a tree diagram if you could possibly draw it. Now, even before solving this 1 mark question, I will um, see how many parts it has. I know that it goes up to a conditional probability for 4 marks. So I'll probably take this space here and draw it on the exam. Right now, what I'm trying to do is I'm trying to show you on the screen. So I'm going to draw it one by one. Janice plays a computer game. She has to complete level 1 and level 2 to finish the game. she is allowed at most 2 attempts at any level. For level 1, the probability that Janice completes it in the first attempt. This question says show that the probability that Janice moves on to level 2 is 0.72. That means that she's successful in her first level. Okay. Now, for the first level, I could say that this is level 1. She could succeed or she could fail. Okay. Zero point 0.6 and zero point 0.4. If she succeeds, she moves on to level 2. I don't need to draw this further. If she fails, she gets another attempt. Okay. This is again level 1 here. Succeed and fail. Okay. If she fails at her first attempt, the probability that she completes it in the second attempt is 0.3 and zero point 0.7. Okay. So probability of level 2 is basically, now again I've moved on to level 2 here. 0.6 plus 0.4 into 0.3. 0.72. I've drawn a partial tree diagram because I had limited space here. I will see that Janice finishes the game. So for level 2, the probability if she fails at her first attempt, she finds the probability. Okay, so I'm going to start drawing this again. And I'm going to say that success, failure in level 1, 0.6 and zero point 0.4. If she succeeds, she moves on to level 2, where she can succeed or she can fail. Okay, I'm going to write small level 2 here so that you know what level I'm solving. This is level 1 again. Okay, this is level 1 again. Succeed and fail. Okay. If she fails, then she takes 0.3 and zero point 0.7. Then if Janice completes level 1, she immediately moves on to level 2. For level 2, the probability that Janice completes it on the first attempt is 0.4. So 0.4 and zero point 0.6. Game complete. So I'm going to write complete. Level 2, success, failure. If she fails at her first attempt, the probability that she completes is 0.2 and zero point 0.8. Complete and not complete. Okay. Success in level 1 takes me to level 2. This is level 2. Okay. In her first attempt on level 2, she can do 0.4 and zero point 0.6. Okay. If she's failed, the game has ended. The game has ended. Here she can do another level 2. 0.2 and zero point 0.8. And this is complete and this is complete. So there are 4 completion points. So I'm going to add up the probabilities. For the first complete, I'm going to say it's 0 0.6 into zero point 0.4. The next one is 0 0.6, zero point 0.6, and zero point 0.2. The next one is 0 0.4, zero point 0.3, zero point 0.4 plus. Okay. 0 point 0.6, 0 point 0.6, 0 point 0.2. 0.4, two 34 over 625. Okay, I'll have to check the answers on this one. Let's quickly check. June 2251. Question number 6. 0.72. Then I have uh, I will have to check if 234 over 625 is 0.3744. Yeah, that is the correct answer. Uh, okay. Find the probability that Janice fails exactly one attempt given that she finishes the game. Okay, so given finishes the game, given finishes game is in the denominator, and that is 234 over 625. And what do I want? Fails once. Okay, so which of these were fails once? This was not fails once. Okay, this one was fails once. Why? Because I see one F and then I see one F here as well. So the second and third, and then she fails, I think, twice. So it's just the second and third. So zero point 0.6, zero point 0.6, zero point 0.2 plus 0 0.4, 0.3, zero point 0.4. Okay, I think that should be the correct answer. 6.6, 0.2, 0 0.4, 0.3, 0.12. Yeah. Okay. So that should give you 0.321. Let me also check on my calculator. I checked the marking scheme for my working. Yep, that is the correct answer. Okay. Moving on to the next question now. I think I'll have to go to a different paper now. Okay. So this one is permutations and combinations from June 52, June 5 to year 2022. Find the number of different arrangements of the 9 letters in the word crocodile. Okay. So I think the last part is tough, which a lot of people have a problem with. I've also done it yesterday on the permutations and combinations file. So 9 factorial, 9 dashes first. Let's put down 9 dashes, 3, 4, 5, 6, 7, 8, 9. So whenever you have permutations, I put down dashes. You can choose not to put dashes and just write me a final answer. That should also be fine. Okay, I am opening up the marking scheme just to make sure that I am doing this correctly. Okay, 90720 should be your answer from here. Find the number of different arrangements of the 9 letters of the word crocodile in which there's a C at each end and the two O's are not together. So whenever you have something that doesn't want to be together, what you do is you keep it separate, you use arrows to represent it, and then sort of find its permutations. Okay, so C's are at each end. Going to write crocodile again. So I have RDILE in the middle. So there are 5 factorial ways of doing that. Then the O's can come up here. Okay, there are 6 places for the two O's. So 6C2 into 2 factorial. What things are identical? Only the O's are identical. The C's didn't get arranged. So I have 5 factorial into 6C2. I get 1800 if that is the correct answer. Yeah, that is the correct answer. Okay, then it says 4 letters of the word crocodile. Find the number of selections in which the number of C's is not the same as the number of O's. Okay, not the same as the number of O's. So let's start solving this question. So I can have no C's and one O. I can have no C's and I can have two O's. I can have one C and I can have nose. I can have one C and I can have two O's. I can have two C's and I can have nose. I can have two C's and then I can have one O. Okay, so number of C's is not the same as the number of O's. Okay, so I have O and then I want to select RDILE. There are 5 letters available. I need to select 3 more, so I'm going to say 5C3. Remember that when you're selecting identical letters and you're counting the number of selections, you're not doing probability right now. So you don't select those, you take them as it is. Okay, so 2 O's, 5C2. 1C nose, 5C3. 1C 2 O's, 5C1. 2 C's nose, 5C2. 2 C's 1 O, 5C1. 5C3 is, I think, 10. 5C2 is 5. No, 5C2 is not 5. 5C2 is also 10. 5C3 is 10. 5C1 is 5. That's another 10. That's another 5. Okay, so total of 50. That should be our final answer. Then it says find the number of ways in which the 9 letters in the word crocodile can be divided into 3 groups, each containing 3 letters. If the two must be in, two C's must be in different groups. Now, I'm not asking you to select letters here. I'm asking you to divide them into 3 groups. So 3 letters, 3 letters. Now, again, the identicals must be separated. So what I'm going to say is that I could have two C's in different groups. So I could have O's with each of them and no O's here. In the last one, I could have O with one of them and one O separately. I could have two O's with one of them and none separately, or I could have a case where I have both O's separately. So for the first case, I need one more letter and I'm left with RDIELE. So I'm going to say this is 5C1 into 4C1 into 3C3. But the problem with this is that CO and CO were an identical group. When I say CO 5C1, I'm counting COR, COD, COI, COL, and COE. Then when I say 4C1 again, I'm again counting COD, COI, COL, COE. I've just reduced one of them. So I've sort of double counted. So what I'm going to do is I'm going to say that there's a double counting of 2 going on since 2 groups are identical. So I'm going to divide by 2 factorial. This doesn't happen here. Why? Because the second group doesn't have um, an O. Okay, so those groups are not identical. Then I have nothing here. I'm going to say that this is 5C2 and then 3C3. 5C2. Now again, I have the same problem here. Okay, so I'm going to divide by 2 factorial here again. So what's 5C1 into 4C1 divided by 2 factorial? I'm getting this and 3C3 as well. Plus, plus, plus. Okay, that I think should give you a total of, if I am correct, it gives me a total of 65. 20 divided by 2 is 10. That's the outcome that I have first. Then I have 4C2 is 6. 5 into 6 is 30. 30, that's 1. 5C2 is 10 into 3C3, that's 10. And the last one is 10 into 3 divided by 2. Yeah, that is all correct. Moving on to the next question. This is again from the same paper. It's question number 7. It says Hannah buys 12 hollow chocolate eggs that each contain a sweet. The eggs look identical, but Hannah knows that 3 contain a red sweet, 4 contain an orange sweet, and 5 contain a yellow sweet. Each of Hannah's 3 children in turn randomly chooses and eats one of the eggs, keeping the sweet it contained. Find the probability that all three eggs chosen contain the same color sweet. Okay, 3 red, 4 orange. Okay, so I think that's simple. R, or orange, 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 or yellow, yellow, yellow. So 3 out of 12, 2 out of 11, 1 out of 10, 4 out of 12, 3 out of 11, and 2 out of 10. This one gives me 1 over 22. No, sorry, that didn't give me 1 out of 22. That gun gives me 1 out of 220. 1 out of 55. 4, 4, 4, 2, 5, yeah. And this one gives me 5 over 12, 4 over 11, and 3 over 10. 1 over 22. So total is 3 over 44, I think. Okay, that's a relatively simple question for 4 marks. I think the next parts are difficult. Okay, it says find the probability that all three eggs chosen contain a yellow, given that all three children have the same colored sweet. Okay, so this is conditional probability given same yellow, yellow, yellow. I think that's also very simple. That's part. I can just write 1 over 22 over 3 over 44. 3 over 44 and yellow, yellow, yellow was 1 over 22. Okay. It's 2/3, I think. Yep. Find the probability that at least one of Hannah's children chooses an egg that contains an orange sweet. So at least one orange. So at least one orange can be done in various ways. I can say that 1 minus probability of no orange. That's the easy way of handling this question. So 1 minus probability of orange not, orange not, orange not. 1 minus probability of orange not, orange not, orange not. So that would be, how many orange nuts are there? 3 and 5, 8. 8. So 8 over 12, 7 over 11, and 6 over 10. This felt like a difficult question. It doesn't really have any difficulty as such. 14 over 55, 1 minus 14 over 55 gives me 41 over 55. Okay, that brings us to the end of this question. I have a lot of other questions now, and I am probably going to be back with another video to solve these for you. Thank you for watching. Please make sure to like and subscribe.